Hello everyone, my name is Swadhantra. I'm a master's student. I'm studying neuroscience here at Indian Institute of Technology, Jodhpur. My research interest is how the brain makes sense of the world, and particularly from the continuous experience or your daily experience, how the brain segments those experiences or chunks them, and how all of this functioning changes as we grow older. So without further ado, let's get started with today's tutorial. Um, so you just learned about multiple linear regression, and I'll briefly explain you why just a linear model might not be good enough for a lot of cases. And let's take a real life example from the human visual cortex and the neurons in the visual cortex. Have a particular tendency to get activated to edges and at particular angles. And the thing is like if you have your y value as the neuronal response and the x as the angle of those edges, it could be that there is no, as you increase the x values of the angle, there might not be a linear regression, linear relation with the y. It could, and what is actually the case that they have the neurons have particular preference, and like as you increase the edge like angle, at some point it will peak, and after that it will slowly decrease. So it will slowly increase, peak, and then it decrease. And this nature is not well won't be captured through a linear model. Just an example with in this data set as well. So here a line fitting would not be appropriate. So in those cases, we can try fitting a polynomial regression, which is still a linear regression, even though it comes like the polynomial terms comes into it. But as long as your a model or the equation or particularly as long as the theta terms do not have any power and are in a linear combination, that is still a linear regression. So what's the difference here is that you try to add orders. You change your x values to some order, and you learn which of these power terms of your input features fits this your output well. So if you have if you have n number of features, then what this does is like we would rather try to estimate each of these m and n features and to power raised to the power k, let's say k. So k could be any value or your max order that you would like to learn, and all of these values will be turned up to this k power, and this will be a linear combination of stuff. So let's, for example, if you have two features, and then and for the first feature, so you are having k3, then you'll have, for the first feature, you'll have like first like let's say x. So x and then x is squared, and then x to the power 3, because you have max order 3. So let's see, let's go and see how you can implement this in our code. So here we are adjusting our design matrix to add all of these powers. So we can learn this combination, or which power terms fit our model better. So here now we just commented out the race non-implementation error. On one shortcut you can use is control and forward slash. This will comment or uncomment any line. Let's go and let's try to code up our design matrix. So here what is happening is that you have your input values here as x, and you're changing that to into one dimension, so you don't have any broadcasting error or matrix multiplication error, sorry. Yep. And then you have your design matrix where you have the you want multiple you don't want whenever you create the design matrix where previously the function would add one more column of ones for the intercept terms, but you don't want that to happen for all if you for all of the features. So here you just add one column of ones before, and then here then you are you need to add up to all of those x or feature values to the maximum order. So here, if your max order is three, here it will this part of code will loop over and add all of those six power terms. So let's go ahead and design it. So our new design matrix will be and we'd like to stack all of those six values or those power terms one after another. So np dot stack, which will so each column is one of your x parameters or the features and raised to the power. So stack x design matrix comma x wait yeah small x to the power your order. Okay, okay, let's try and run this thing. Yeah, okay, okay, I got it. So yeah, just this one. You need double brackets. Okay, this is matching. So now we'd like to fit the polynomial regression model and see how well the fitting is happening. Then let's go ahead and do that. So to solve the polynomial